Hello, CATIA users. So I wanted to give a quick demonstration for my students on how I use bodies within my best practices. Um, if a student in my one of my classes is going to use bodies, will use bodies, then I expect that student to follow best practices that I have established. I've been using these for several years and um, seems to work well. It also is a good transition to working with surfaces. So this one though will be straight from the part design workbench. So I've got it established. You can see the part here. It's got a shaft. It's got a hole pattern. It's got a neck. It's got a center hole. So if I'm looking at this, I've got really one positive space feature, which is the shaft. I do have a fillet, which is a dress up feature. I have a center hole. I have a bolt circle pattern of holes. So if you're looking at my tree, and the way I have it organized is I use geometric sets for sketches. So in this case, I've got two sketches. I've got a, a basic shape sketch, a sketch for the shaft feature, and then I've got another sketch, and I've got them visible here so you can see them, but I've got another sketch for the groove feature. Then I also have a separate geometric set for any reference geometry, in this case planes. So I have a, a offset reference plane that defines the height of the flange, and then another plane that defines uh, another height dimension on the flange. So if you look at the way I've got this organized, so I've got the part body, and then I've got under it as a child body is I've got added in with a Boolean add operation. I've got another body I called finished part. So this body is a collector body for positive space bodies and negative space bodies. So immediately following the finished part body, I have an add body, and that add body is added in first under the finished part, and it holds any positive space bodies. In this case, I've only got one. It's called flange basic shape, and it includes a shaft feature and a finished dress-up feature. So one of my best practices that I follow is that there will be one sketch space feature per body. So notice I've got a body and it's called flange basic shape and includes a shaft. The one sketch space feature is the shaft itself, and the sketch is down here in the sketch is geometric set. But notice you won't find multiple um, sketch space features. You can have multiple dress up features though, but in this case only one sketch space feature. And this is the only positive space body I have. So this add body we only have one sub body under it because it only has one sketch space feature. So as I come out of this, I've got a finished part, and I come back, and then I put my removed bodies, negative space bodies, into a body called remove body, and it has a remove Boolean operation. And in this case, I've got three under here. So I've got a center hole, which a hole is a sketch space feature inside of CATIA. So I've got the one hole here. And then I've got a bolt circle pattern, and a hole again is a sketch space feature, and it has a pattern. You can have as many dress up features and transformation features as you like in a body. And then finally I've got the groove, which is a sketch space feature. So notice I've only got one sketch space feature under groove, and I also have a tri-tangent under here. So what I want to do is I'm going to break this out. I want to take away all the Boolean operations and reestablish how I created this. One of the most important rules is, again, I want to reiterate this to my students: one sketch space feature per body, and adds go before removes, and that should make sense. So I'm going to start at the top and just work my way down, removing these Boolean operations. So I'm going to take out the delete, and I'm not going to delete aggregated elements. And under finished part, I'm going to remove this add. Again, never removing aggregated elements, else you're going to lose everything under. Um, my sophomore level class I teach at Central Michigan University, we get into some bodies, but just minimum. But when students take my surface modeling class, which is a senior level class, we do work with bodies when they have, so I expect my students to be comfortable working with bodies when they get into surface modeling, even though surface modeling is, of course, surfaces and these are bodies. I do integrate surfaces into parts. So I think I've probably got this deep enough. I've got everything broken out. So I've got everything broken out into the individual bodies, so nothing's within its own order of regeneration. So I start at the top and work down. Now, so I'll go to the part body, make that my defined working location, and it's already there. So I can add in, I can add the finished part. So I've got part body, I've got my defined working location. I want to add in the finished part into it. So I pre-select it and I can go insert Boolean operation, add, and the way I select, everything should be correct here. And so I have my finished part sitting here. Next, I can go into define work location, make that the define work location, and I can add my add body in. And notice I forgot to break this out. That's okay. Similar process. Well, I'll tell you what, I'll break it out real quick. Just going to turn right around and put it back together, but that's okay. It's a demo. So I've got a finished part, so I'm going to select add body, insert Boolean operation, add. See that back under there. Now, make that the defined working location, and this is a right click, define and work location. Go back to that add body, that flange basic shape that I just took out, and put it back in. So make that the defined working location, pre-select here, insert Boolean operation, and add. And I'm done adding positive space bodies. So I'm going to go back to finish part, make that the defined working location. You can see it's underlined. That makes it the way to show that where you're currently working. So I'm currently working under this branch of the tree. So I'm going to add a remove body in. So pre-select my remove body. And this is the only negative space. I'm sorry, this is the only Boolean remove I'm going to have in the tree. So make a Boolean remove here. And then define a work object for the remove body. And these three, I'm going to do a Boolean add on these three. I don't care what order they go in. So I'm going to pre-select all three. I can do them all at one time and with a Boolean add operation. So now, whenever I make the part body the defined working location, it comes out like I like it, the way it should look. So back up, just to reiterate a couple more things here, or review some stuff again. Within each body, only one sketch space feature. That's important for me. You can have as many dress-up features as you like. I try to put dress-up features in the lowest level possible. As an example, this fillet here, this edge fillet, I could have placed somewhere else, but this is the lowest level I could put it, so I went ahead and put it in flange basic shape. I've got a tritangent here that's under groove, and what that is just a rounded inside. You can see there. Let's say I wanted to add a fillet here, I would probably just come back and I can modify, just add a edge there. Sure, kind of edge. Yeah. So one of the reasons why I like working with bodies this way is it allows me to go back and insert, modify. Even sometimes I have to remove bodies just to work on them a little bit, and then I can insert them back to where they were before, at least at the bottom of the body where they were currently residing. So this allows me a lot of flexibility. I do use reference planes more often here. So as an example, so I created my sketches and I put them in a separate geometric set. So one of the things I like to try to avoid when I'm working with bodies, I do not like grid turned on. There we go. One thing I try to avoid when I'm working with bodies is referencing geometry in another body, if at all possible. So I will put in reference planes more often. So as an example, I've got a reference plane here and a reference plane here. And instead of having height dimensions, I'm tied in with coincidences to these reference planes. And so if I want to change the height, I can change the height of the reference plane. What that allows me to do is whenever I go to put in my holes here, the placement plane for the hole, in this case, the first hole before the pattern will be the reference plane versus the top of the shaft. So by using the reference plane, I'm referencing that reference plane versus referencing this topological face of this shaft feature. So that helps cut down on some regeneration errors. So I always try to avoid, if possible, referencing geometry in another body. So the top center hole here, the coaxial hole, I'm referencing that plane versus the top of the part. That allows me to not worry about that topological face being a parent of the hole. So it shouldn't matter in the long run, but sometimes it does. I think it does make the model a little bit more robust. So that is working with bodies for me. Now, if this is surface modeling, I don't have a lot of, if I'm working with surface modeling, I don't have a lot of remove bodies. On occasion I will. Occasionally I will. A lot of what I have is solidified surfaces that are treated as a sketch space feature. So whenever I say one sketch space feature per body, the actual rule for my surface modeling class is one sketch space feature or one solidified per body. So that allows me to incorporate multiple solidified surfaces into a Boolean operation.